You can see three equipotential lines in the diagram, whereas a point mass whose mass is 2 kg is placed one of the equipotential surface. In this question, you have to find out in which direction this point mass will move if you release it, and it will move due to the gravity of the planet, and what will be the change in potential energy, which actually depends upon the work done. So we can find the work done as well, because we are given the gravitational potential values. Okay, so let's start from the very basic concept, that you can see that these are not field lines, and the field line is always perpendicular to the equipotential surface. So right at this point, this dotted blue line is the field line, whereas it's also a field line. So I can resemble the situation with the earth like this, where this is a field line, this is another field line, and you can say that this is a mass present at this point. So for example, if the mass, let's say, is placed at this point on the surface of earth, then the potential energy due to the gravity is equal to negative g mm over capital R, which is actually, remember, it's a maximum negative value. And why I'm saying it's a maximum negative value, because this distance capital R, radius of the planet, is the minimum distance right now from the center to the object. So when you will take the object away from the surface, this orbital distance, or the distance from the center, will increase, and when it will increase, the potential energy will become in fact less negative. That's a very logical connection, that if you increase this distance, then it will become less negative. That what we exactly see in these equipotential surfaces. So we can say that the negative 85 kilojoules per kilogram is closest to the planet. So we can assume that actually a planet may present here. Why not? So if this is a planet here, then it means that the field lines should be directly towards planet. That's why it must move towards left. Okay, now the next point. We are given the equipotential values, potential difference values, potentials values, and you know that the potential is equals to the work done per unit mass, and the potential difference is equals to work done per unit mass to move it from one equipotential surface to another. So you can take any two surfaces. So it is moving from negative 65 to negative 85. Let's find out the work done. That will be equals to the potential difference into mass. So if you take a difference, final potential value is negative 85 minus, due to the difference, into minus 65 kilojoules per kilogram times the mass is 2 kilograms, times 2 kilogram, and kilogram inverse will cancel out. Answer will be in kilojoules. So hence it is negative 40 kilojoule. So this is the change in potential energy as well. Okay, in other words, like, you can see that the potential energy change will be negative, because you are moving from less negative value of potential energy to larger negative potential value. So when you will take difference, it will be negative. So it is negative 40 kilojoule. So the right answer is B.